Universal asynchronous receiver and transmitter. Part 2. This is the logic circuit of the UART circuit inside the C8051F226 microcontroller. This is the baud rate circuit, which is responsible for generating the transmit and receive clocks. The transmit terminal is responsible for sending out the serial data. The receive terminal receives serial data. Data transmission is started by placing a byte of data into the transmit buffer called the S-buf. This is done by software. Received bits from the receive terminal goes into a shift register. When data reception is complete, it is transferred to the receive serial buffer. The receive serial buffer is also called S-buf. The received data stays in the receive S-buf, and can be retrieved by the system software through the system bus. Let's look at a simplified diagram of the transmit and receive circuit. When data are placed in the transmit S-buf, it is sent out serially. Upon completion of the transmission, a bit called the TI in the S-corn register is set to 1. The TI bit can be cleared to 0 by software. Received data goes into the receive shift register. When data reception is complete, the data in the receive shift register is transferred to the receive S-buf. At the same time, a bit called the RI bit is set to indicate that a complete data resides in the receive S-buf. Let's take a closer look at the S-corn register. The TI bit is called the transmit interrupt flag. It is used to indicate that a transmission has just completed. The RI bit is called the receive interrupt flag. It is used to indicate that a new data has just been received. To transmit data, simply write an instruction to equate S-buf with a data. After transmission is completed, the TI flag can be cleared by equating TI to 0. What if multiple bytes of data need to be transmitted? Can you write multiple instructions equating S-buf to some values? Observe what happens when this is done. Before each data is completely sent out, the next data arrived at the transmit S-buf register. Therefore, data are not properly sent. This is how to properly send multiple data. After data is placed in the transmit S-buf, wait for the data to be completely sent by monitoring the transmit interrupt flag. While the flag is 0, the program runs in the empty while loop. When transmission is complete, the transmit interrupt flag becomes 1. The program skips out of the while loop and continues. At this point, the transmit interrupt flag should be cleared to 0. Repeat the same instructions for each set of data to be sent. When receiving data, check for the receive interrupt flag. The received data can be transferred to a variable by equating the variable to sbuf. After the data is retrieved, the receive interrupt flag should be cleared to 0. A while statement can also be used to monitor the receive interrupt flag. While RI is 0, the program will hang in the empty while loop. After retrieving the data, RI should be cleared to 0.